Welcome to the topic of cardiac electrophysiology. Today we're going to be focusing on how to approach a reading electrocardiogram. You're probably wondering, how do I approach EKGs or ECGs? Depends on which side of the world you're from. In the United States, we call them electrocardiogram with the word EKGs. In the United Kingdom, they call it ECG. It's the same thing. So don't worry yourself too much about that. So what are the basic highlights we're going to start with? I'm going to start by describing what an electrocardiogram is. What do we use it for? Why is it helpful? Well, let's break the word into three actually. The word electrocardiogram, that's three words. Electro means using electrodes or wires, and cardio means heart, and gram means to write in Greek. So we are trying to find out exactly how we can read how the distribution of electrical activity inside the heart muscle can be displayed on a two-dimensional piece of paper. That is pretty amazing, right? The heart is a three-dimensional structure. How can we make a three-dimensional structure and interpret the data that's giving us into a two-dimensional structure, which is a piece of paper, and be able to give us an exact picture of what's going on in your heart at every single point in time? Well, this is very useful in the healthcare industry, especially in medicine. We order EKGs all the time. And one of the main reasons why we order EKGs, reason number one, is to check for cardiac ischemia or infarction, such as acute myocardial infarction, right? Which is referred to as a heart attack, or if there's not enough blood flow to one part of the cardiac myocytes, we can be able to detect it on an electrocardiogram. Also, the EKG is extremely useful to tell us if there's a problem in the wiring system in the heart. We call that arrhythmias. And we're going to talk a lot about different kinds of arrhythmias later on in the different chapters. But right now, I just want you to realize that this gives us a lot of information as to how the heart is functioning. That is why EKG is very, very important. Well, now that we know what an EKG and what we use it for, let's progress to learning the structures. The structures actually compose the part of the heart that's actually doing this. So, we are really focusing on cardiac electrophysiology. On the right hand side of the board, I have drawn out the human heart. Now, we're just going to go over the structures of what makes our heart function. Well, let me oversimplify before we progress. The heart, it's a pump. And the pump needs an electrical wire to get it started. Just exactly as you turn on your switch of, you turn off your lamp inside your room, you need an electrical wire to run into it. It gives it current and it glows. The same thing in the heart. The heart needs an electrical current. And that electrical current is going to make the cardiac myocytes or the heart muscle contract. So you fire electricity through the heart and then it contracts. And that's what keeps the pump working. If there's anything that disturbs that pattern, right? Someone switch off the power supply. Oops, that's not good. Well, the heart is going to stop pumping, right? It goes into a systole. That's the fancy word for it. It's not working, right? Or if something wrong in any of that track, and which we're going to talk about in full details, the heart starts to malfunction. So we have four chambers in the heart, right? We have the two atrium, which I've drawn up here, and we have two ventricles. We have the left ventricle, and we have the right ventricle. We also have the left atrium and the right atrium. It's on the 4 chambers. Now, there is the electrical system in the heart, which start at the top of the right atrium. That is called the sinoatrial node, also known as SA node. So whenever you hear SA node, that is the sinoatrial node. That is the source of electrical activity inside the heart. Now the SA node, as you can see in green, actually tracks over. See, it tracks over into the left atrium and also branches down, forms all this wires. See all this wiring coming down and forms and meets with this other node, which is the second node in the heart, known as the AV node. What is AV node? AV means atrioventricular node. Let's take that word and break it into two. It's between the atrium and the ventricle. The atrium and the ventricle. That's the AV node, atrioventricular node. Now, the next structure, we just talked strictly anatomy now, is this His bundle. The His bundle. It's like a bundle of nerves, which is not going to go into the septum of the heart. This is the septum of the heart. Now, what do we mean by septum? Septum is anything that separates two chambers. So in the septum, we have this branches coming in. We have two branches that's got the big thick nerves running in the middle. One goes to the left side of the heart, which is going to the left ventricle. So that's known as the left bundle branch. That's the first branch. That's one that's going to the right ventricle is known as the right bundle branch. This nerves, fibers, are now going to go all the way in and bury deep into the ventricular muscle, which is also known as the cardiac myocyte, and spread out all the way through to form the Purkinje fibers. So how does electrical activity go through the heart? From the SA node down to the AV node, through the His bundle, down the bundle branches, which is the left bundle branch and the right bundle branch, and then eventually form the Purkinje fibers, Now, what is the SA node? Well, the SA node is also known as the pacemaker of the heart. Pacemaker. Well, what does pacemaker mean? Pacemaker means the origin, the start. What's going to generate the electrical activity that's going to get our heart pumping every day. That is known as the pacemaker. And then we're going to talk about a lot more about how this pacemaker works and how these action potentials are actually being performed inside this pacemaker. But that is the general overview. I want you to commit this picture to memory. Extremely important that you remember these structures, because every time we talk about electrical activity in the heart, always remember it starts at the SA node, down to the AV node, right? And then to the His bundle, down to the bundle branches, the left and the right, and the Purkinje fibers. So occasionally later on when we talk about bundle branch blocks, well, here's the left bundle. If I block it, you can develop a left bundle branch block. If I block this right bundle, you can hear a right bundle branch. These are fancy words we're going to throw around later on in subsequent lectures. But it's extremely important that you keep this at the back of your mind, because this is how we're going to approach cardiac electrophysiology. Now that we've talked about the anatomy of the conduction system in the heart, let's now move on to the next lecture, which will be the cardiac action potential. So, what is the cardiac action potential? We are going to start with the SA node. The SA node, which is known as the sinoatrial node. channel, atrial node. Now, we already said the SA node is the normal pacemaker of the heart. Well, this pacemaker is actually a cell. So let's draw out a cell. Let's draw out a cell, and we're going to use this as an example of a pacemaker. Now, remember, cells actually have a membrane, right? And on this membrane of these cells, they have channels. They have protein channels. So I'm going to draw a protein channel here. That's a protein channel in this cell. So this is the SA node. Now, this SA node has an unstable resting potential. Wait a minute. We've never heard that word before. Now, this is a good junction to talk about resting membrane potentials of cells. Hey, thank you so much for watching the video. I hope you learned a lot. Are you studying for the USMLE Step 1 or Step 2? Are you studying for the NCLEX, or you're currently in nursing school as a nursing student? Are you a PA student currently in school or studying for your PANCE exam? Or are you a nurse practitioner student or trying to take your NP board exam? Listen, I've got super awesome content for you. If you truly love this video and it simplified your learning process, I want you to check out my website below. I've listed all the list of exams, whether you're studying for any of this board exam, and all I want you to do is click on the link right now below so that you can take you directly to my website. For USMLE, just go to smashusmle.com. For NCLEX, go to crushnclex.com. And if you're studying for the PANCE exam, the nurse practitioner exam, or you're studying for your internal medicine board exam, just click below and it'll take you directly to ftplectures.com. Listen, I can't wait to help you. If you need to get in touch with me, just get to my website, you're able to reach me directly, and we can work together one-on-one. Listen, you're super awesome, and my goal here is to help your dream come true. If you want to be a doctor, want to be a nurse practitioner, a registered nurse, or physician assistant, I'm here to help you get to that next level. With your medical knowledge, let's save the world together. I love you guys. You guys are super awesome, and do not forget to click on the link below to be able to get to my website. Also, don't forget to subscribe to my channel. You guys have a great day. Let's go.